Okay, you've already worked with putting a system of two equations into Desmos and finding the point of intersection, but you're also going to need to be able to do it by hand. And so I want to do a couple with you, and it's a good review from first semester on the equations of a line. So if you recall, the equation y equals mx plus b is called the slope-intercept form of a line. The reason we call it that is because the m value tells you the slope of the line, the amount that it's slanted. And this number that's in this spot, the b value, is the y-intercept. It's where the line hits this y-axis. So to solve this system, we need to graph both lines, and we're looking for the point of intersection. So this equation has a slope of 3 and a y-intercept of 1. So we go to the y-axis and we go to 1 and put a dot. That is one point that the line goes through. And now from this dot, we're going to do a slope of 3. Well, just to review, slope of 3 really means 3 over 1. And the top number is what we rise, the bottom number is what we run. So we have to rise 3, so 1, 2, 3, run 1. And then you take a ruler and you connect those 2 points with as much accuracy as you can, and you extend the line all the way through all the quadrants. Second equation, y equals x minus 3, the slope is going to be positive 1, because it's the coefficient here, and the y-intercept is negative 3. So we're going to go on the y-axis to negative 3, and a slope of 1 means we rise 1, run 1. And then I'm going to use my ruler to connect and extend. And it's important to extend your line out because remember, we're looking at that point of intersection. If you don't draw your line far enough, sometimes you might not catch that intersection point. Down 3 over 1, down 3 over 1. Okay, so this didn't come out to be super exact. And what I mean by that is notice that it's falling halfway between negative 2 and negative 3. So our x value is going to be negative 2.5, and our y value is negative 6. That's the ordered pair, and so that's the solution to our system. Okay, take a look at the second system. And I'm going to do the second line first because it's already in slope-intercept form. So this has a y-intercept of negative 1, and our slope is negative 3/5. So that means we have to go down 3, we rise negative 3, and then we run always to the right 5. So always go down 3, but you're always going to run to the right. And if you remember from previously, whenever the slope is negative, your line should be going downhill. And when we graph this, we can see that we did it correctly. It's a decreasing line from left to right because the slope is negative. Okay, but this equation is what I wanted to show you about because you will see this on your test. This is not in y equals mx plus b form. This is in standard form. So in order for us to graph this, we need to solve this equation for y. So to get y by itself, we need to move this 2x to the other side. And we do that by doing the inverse operation of what's happening right now. So 2x is being added to 5y, so we are going to subtract 2x from both sides. So we get 5y equals negative 10 minus 2x. Just as a review, when you subtract 2x from positive 2x, those cancel. And the last step is to get y by itself, we have to undo multiplying by 5, which means we have to divide everything by 5. So we get y equals negative 10 divided by 5 is negative 2, and negative 2x divided by 5 is negative 2/5 x. So now this equation is in slope-intercept form. The slope is the value that's attached to the x. So we have a slope of negative 2/5, and this has a y-intercept of negative 2. So I go on the y-axis to negative 2, And now from this point, I'm going to rise -2. So that means go down 2 and run 5. So that means it's going to go through that same point that the other one did. And you can see that these two lines intersect clearly at this ordered pair, which is the ordered pair 5, -4. And just to tie it all together, the first line has a slope of -2/5. The second line has a slope of -3/5. And when two lines have different slopes, they have to intersect in one point. Make sure that these two examples gets put into your notebooks so that you have something to work on or look at for the test.